So I'm Simone from Rome, Italy. I recently moved here, actually 2 weeks ago, but I've been coming often in the past 3 years because my girlfriend lives here. So thank you, Florian, for giving me the opportunity as a welcome to the city, let's say. My background, I'm a software engineer, co-founder and CTO of Omea. We are a UK-based health tech startup, and a bit of my story on how I ended up working in health tech. So in the past 4 years, I was working in crypto, burned out many times, and that came, like March 2025 on the left. That's me. I was diagnosed with a chronic thyroid condition, nothing like crazy, but still, that got me back on track, or at least, like the motivation to get back on track. And that's when I started measuring everything in my body, like from blood tests. I bought one of these wearables. I have Whoop, tracking my sleep, doing more trainings, really, going crazy with it. And that brought me in co-founding this company with 2 people in the UK. And this tipping point that you see here, it's actually the last time I spent 2-3 months in Lisbon in March. You can clearly see when I actually left crypto, it's my hands dramatically increased. So what we're building is a mobile app where you can book or upload blood panels, connect wearables, enter your medical history and conditions, and we generate for you in a deterministic way a protocol of actions that you can take in order to improve your health, to avoid getting worse condition in the future. I mentioned that it's deterministic, and this is very important. So it's not AI analyzing and guessing what's best for you to do. We have a medical team actually hiring this week the chief medical officer. So we're very early. What I'm going to show you today is the first time I'm showing something about Omea. This medical team, of course, is responsible in supervising all the clinical governance, the research, and everything that makes the protocol hopefully relevant and working. The problem with that is that like this research work that they need to do is incredibly intensive, time intensive, because think about there are 800, 900 possible interventions that one can make in order to improve their health around supplements, diets, movement practices, sessions like acupuncture, and so what I'm working on right now for them to facilitate their work is an autonomous research pipeline that is divided in 5 stages, and these hopefully will help them validating this research and creating this protocol library in a much faster way. So the goal is to give them all the data points and the context they need in one place in order to then decide, okay, this intervention like magnesium to improve your sleep, how real is that? How is the impact? Is it benefit, worse, whatever? How does it work? So there's a 4th step where we, this CLI calls Europe PMC, a database of research papers. We get 100 to 200 papers. The LLM re-ranks them by relevance with respect to the question. So a question is magnesium actually improving sleep? So the LLM ranks the best papers, how they are central to this question. It judges each of these papers according to, I don't know, how many people, what type of tests and research they run, and finally aggregates the result in a single verdict and grade. All of this goes into a medical dashboard that the clinical team will then use to validate it. So what I'm showing right now, it's a live demo. So on the background, I have a cloud terminal on with monitoring for events. So these events that is monitoring is basically on here. I can type any kind of intervention I want. It could be magnesium with anxiety in this case. I can pick one from here, cold exposure with respect to inflammation. Top right, you can see it's starting to do its work. It's gonna take some minutes, so I'm gonna first show an example that I created earlier this week. So magnesium with insomnia. As you can see, we found 78 papers 31 had open access, some were meta-analysis, some randomized clinical trials, ordered by citation. Of these 78 papers, we only kept 15. Each of them got a grade, direction, it could be low, moderate effect, very low. If there's a spin flag, it means that the study is not very confident, and so the AI is flagging this paper for the clinician to review manually. Right now it's actually judging the papers. And this all happens in a CLI. So bottom left corner, unfortunately, is cut. You can see there's like a command line text that you can enter in order to run this pipeline for any of these interventions that we mapped. The result is a grade from A to F. In this case, the result for magnesium is a C. It means that the evidence is limited or like not enough. The effect should be like moderate improvement, but the evidence is not actually backing it well. You can see how we craft like this score and confidence. So we have a 50% confidence on this C, and it's because of the meta-analysis volume, the consistent direction of the studies that we made, the coverage, but then we miss replication maturity, outer concentration, and other parameters. So there's this is the deterministic part. So once the LLM analyzes all these papers, we extract like 30 fields, and they feed into this algorithm to calculate the score. We also compare it with the examine.com, which is a human curated reference, just to give another input to the clinician. The final result is this. So there's a dashboard that I'm going to show you where the clinician will see the pair, the verdict of our pipeline, the reference from Examine, the integrity audit of the papers that we analyzed, and finally we propose them a grade. So in this case, the grades are from S1 to S4 according to how strong is this evidence for the intervention, the direction, if it's benefit, no effect, or whatever, and the magnitude, and then the list of papers. In the meantime, this is the result of the cold exposure. So cold exposure towards inflammation is still a C with 20% low confidence. Why? Because the signal, as you can see here, the signal points to benefit, but it rests on 2 relevant papers out of 10 that we kept. No eligible meta-analysis, no pooled sample size, no independent replication, and 1 overstayed their abstract. And so, going back to the dashboard here, there's a lot of things happening. Maybe I just zoom in. So the clinician and the medical team will have a review queue that, of course, in the beginning will be huge, but hopefully in time it will be just daily, weekly, monthly updates. And they can go into this entry here for cold exposure inflammation. This is a new triage because it's not in the system yet. They can see the verdict, all the data that I was showing you on the screen, just in a much easier and navigable way. So here, for example, they can see all the papers that we judged. Only 2 were used in the grades. Even if we judge a date, because the grade that we judged was very low, there was not enough confidence, and so we discarded them. And finally, again, they need to add it to the library so they can decide if it's actually a strong evidence tier, it's a weakest one. They can decide if the verdict magnitude is small, moderate, large, the direction, and then approve. Yeah, this is broken still, but that's pretty much it. It's very early. Again, I still need to have this reviewed by the chief medical officer that is coming on this week, but it's a starting point. Thank you.
That's the beauty of a live demo, showing broken things. So I guess the takeaway is don't work in crypto.
if you care about your health, maybe.
Okay.
Are cold plunges overrated?
That's actually what not only this evidence, but we interviewed a lot of chief medical officers, and most of them, like we gave them a task to, let's say, score all these new intervention, fancy ones or overlooked ones, and they all say that cold plunges, there's no like real evidence behind the positive effects. But I still do it.
This is cool. There's like a replication crisis in medicine, and like there's a lot of like p-hacking and stuff that happens in papers because like you got to publish. Like, have you got guardrails and safeties to try and like weed out papers that I saw? Like, for example, you had one where like the abstract overstated the conclusion. Like, are you how deep are you going into that paper and figuring out if it's high quality or not?
So initially I was going very deep, not just using like multiple passes, even on the full text. But then what I saw, by talking with some people working with a lot of these in biology, that most of the information usually is in the abstract, and it actually it's real that the abstract is providing, like if you enable the full text, most of the times the grade that the LLM will give you is the same as just with the abstract.
And save tons of tokens.
Save tons of tokens, but also one insight that they gave me is that these LLMs today, I used Sonnet for this one, not Opus, not Fable yet, but there was no big difference between Opus 4.8 and Sonnet, but these LLMs today can easily judge this thing on their own, so without parsing or doing some like pre-processing. They told me just give it to the LLM to analyze, and it's enough, and that's what's coming out of it. So again, I still need to review this with the medical team to understand if this is actually useful, truthful, because my background is not in medicine, so I'm kind of limited on that side. But that's how I did it. I didn't write a single line of code, by the way.
Half is verified, the other half approves. And we've got room for one more, and then we need to go on.
Hi, thanks for sharing. I found your slides/demo quite interesting. Like, you embedded the app itself in the slides somehow.
Mm-hmm.
I was just really curious, like what stack you're using for this, and how you put it all together. This is really cool.
It's an HTML and an MJS server. Even for this one, I didn't write a single line of code. I started with the slides, then of course there was the no policy slide, and so I didn't want to just show here and be typing with the CLI, because it's not what I'm going to do in the end. Like, it would never happen that I'm typing that command here. It's just, I asked Claude or Codex to do that for me, and so what I did is having an HTML where I can input stuff. So here I can search from that's a JSON that I loaded. And then what happens when I send this, there's a monitor that is here, it's running, and it's waiting for events coming from whenever I send the pipeline to run. And this is polling in real time the status from what it comes from here. So if you, I don't know if you notice, yeah, here it's also sharing things that it's doing. So it's searching, it's retrieving candidates, re-ranking them, appraising each paper on the grade, and so in real time it's fetching data from what the LLM behind the scenes is doing.
Thanks. One more.
Yeah.
Anyone else?
Yeah.
One more question?
Okay.
Thank you.
Thank you so much.